flat version of the zinc bromide cell. I used the same electrolyte that came out of the flow cell itself. So the voltage was 1.9 after an hour and 45-minute charge. So far we're at 45 milliamp hours and 76 milliwatt hours on a 50 milliamp load, and got to about 43 minutes and I think it's starting to go flat now. So it held 1.7 for a very long time, to about here, to about 43 minutes, 1.7 volts. Not too bad. I might seal it up in a bag, add some electrolyte and see how long it actually lasts. I think it's pretty flat now. Don't know if we want to go any further, so I'll stop the test. It might damage the cell, I'm not sure yet. So recovery is not too bad actually. That's the fourth charge. I had 3 half-hour charges and the cell didn't perform, and then 1 hour charge and the cell still didn't perform, and then a 1 hour and 45-minute charge and the cell just produced this. And we're back at 1.2. I think if we go past this point we're going to start degrading that cell. It's just carbon felt with some zinc hexacyanoferrate mixed into that when it was mixed with the feather carbon in the mix on the positive side, and the Iron III Hexacyanoferrate III on the bottom side. I've got the electrolyte was mixed with the carbons and no binder was added, and I also have the material, carbon material under the felt pad, which is touching the graphite pads on both sides, and it's out here because it really fumes. It smells pretty bad. Okay, we'll be sitting there, so I'll check it tomorrow after work and give it another run. Could be promising. If it lasts, it's not a bad cell. If it stays in that form and works for I don't know, a few charges. Yeah, we're stabilised at 1.2. Now it's dropping, so it probably leaks a bit. Alright, till tomorrow. Okay, it's the following day. I found the cell with 0.01 of a volt with the paper towel as a separator, so I imagine it just leaks. So I'm trying a bit of celgard. It's only been in there for about half hour now, so I haven't got a charge on, but we do have a voltage, so it sort of may work with the acidic nature of the zinc bromide, perhaps. So I'll give it another, well, it's 1:12, so I'll have some lunch and I'll get back after lunch and see if the celgard's improving. So it's got a higher voltage now than it started with, and I sort of did do a charge, but see the milliamps, it was like 1 milliamp. I mean, it was like 0.001 milliamp going through the cell. Alright, I'll be back. Okay, back. It's been 2 days trying to wet that celgard. What's happened now is it seems to have swapped its polarity over, so that's the zinc side, zinc hexacyanoferrate side is now the negative, and the positive is now the Iron III Hex III carbon mix, and we're currently sitting at, it's on the 2 volts, 0.076, not even moving that. It's bouncing around. So it's definitely, it's on positive voltage, but it's at very low voltage. But it seems to be fluctuating weirdly. Could be the new power supply. That was $98. It delivers 10 amps, 30 volts. Not too bad for 98 bucks. So I'll get this set up to the laptop and pull it out of that jar. I'm going to turn all that into bromide, or bromine I should say. Might start fuming. It's pretty windy out here, so fumes shouldn't be a problem. Alright, so I'll get back and set that up. Okay, I've connected it to the data logger and the charge. We're delivering 0.022 milliamps at 2.1 on the data logger. It's not registering how many milliamps going through there. So celgard may not be working. Not as good as that paper towel. So celgard's just probably for lithium anyway. Just, even if that's not even real celgard. Not sure. It said celgard. I forgot what number it was. That was ages ago I bought that. Thought I'd try it in an acidic environment, but obviously not working. But we'll test it for a while and see what happens. It's sort of dropping. I doubt if the cell's going to run. So I'll give it about, I got some things to do, so I'll get back in an hour maybe. And if it doesn't work, I'll put a paper towel back in there and be done with it. Or actually I might soak a piece of tracing paper in there now while we're waiting, and maybe that will absorb the stuff and be ready to be used. Okay, it's been on for 35 minutes and I just adjusted the voltage to 3 volts. Now we're drawing some more milliamps through the cell. So I'll give it another hour. I mean, half hour, maybe an hour and a half, or an hour. Get it right. Alright, I'll get back. The cell's been on charge for 2 hours and 26 minutes. After maybe 30 minutes, I turned the voltage up to 3.1 and we hit nearly 450 milliamps, and it's been going down. These little spikes are where I added some electrolyte just to stop it from drying out. So it's made its way down to 70 milliamps. So I'll disconnect the charge and set up the data logger and I'll get back. I'm not sure if the membrane's gonna work. Like our voltage might just drop off to 0. So I'll get back and we'll see. Working. We've dropped right down to 0.3 volts without a load on. And it's leaking. So a bit disappointing. For I wasn't waiting around, I was doing housework, so let's start, see if it actually runs 50 milliamps. Just drops right off, bugger all voltage. Okay, well we're not even doing 50 milliamps. Oh well, I'm going to wrap it up for today. In there I have a piece of tracing paper. That'll be good for tomorrow, so I'll set that up tomorrow and repeat. So celgard, no good unless it's a lithium battery. Okay, signing out. Okay, back the next day. I've just connected the charge up. We're at 2 volts and we're putting in 315 milliamps. I've got a piece of tracing paper this time as the separator. It's been soaking in the electrolyte overnight. So I'll charge it up. It had a slightly higher voltage than the celgard. It was at 0.1 this time instead of 0.01. So we'll see how this goes. And if it doesn't work that well, we'll go back to that paper towel. It may hold the active material. See how it's gone that funny colour there? That must be bromide. bromine. Alright, I'll get back in about an hour and a half to 2 hours. Piece of celgard. I notice it tears in little string-like fashion, especially if you try to cut it with blunt scissors. It just strips down the side. So the Iron III Hex has stained it. As you can see, it pretty much stains everything it touches. It bleeds through heaps. So a lot of the Iron 3 is probably out of there now. We only started off with 1 gram each side of the stuff with carbon mixed. So 0.5 grams of the Iron 3 and 0.5 grams of the feather carbon. Yeah, we've been on charge. The charge curve's a bit different. Dropped straight away there in about 2 minutes nearly. And now it's slowly going back up. So maybe it needs a paper towel to hold the stuff in there like that. I'm not sure. I'll keep going. It's starting to eat my little alligator clips. I tried to keep them clean, but it leaks. It sort of creeps up and grabs hold of them. The electrolyte. Okay, the cell's been on charge for 2 hours and 12 minutes. Dropped down to 129 milliamps at 2 volts. So I'll disconnect the charger and I'll get back. Okay, I have the cell now disconnected from the charge and connected to the data logger. It's 1.8 volts, which is good. The separator definitely makes a difference. The celgard over there is totally no good for this version of the cell. So I'll start a 50 milliamp load. Starting now. Hang on, I'll adjust that 10 milliamps. 150. Okay, we're at 50 milliamps and we're holding 1.8, which is not too bad. If the I might bag it up to keep it moist and see how long it actually lives for, because 1.8 volts is quite good. I think it acts more like a supercapacitor though, because the next day it's 0 in power. But at 50 milliamps it's holding its 1.8 quite well, much better than that flow cell, which had a bigger surface area. Compared to that, it's only 40 by 40-ish, I think, around about that. And as you can see, the voltage drops not too bad. It's pretty slow. Well, it gets to a point and then it just drops right down. So I'll get back and see what happens. Okay, cell has been running for an hour and it's holding 1.7 volts, but it's starting to drop there. We're at 50 milliamp hours and 90 milliwatt hours. Average voltage 1.79. It'll probably get to 1.6 and start dropping rapidly. So I think it's slightly improved compared to the paper towel one as a separator. It did have 15 minutes longer charge though compared to that one here, see? So we're dropping down now, 1.6. Sort of voltage is still holding stable. Oh no, there she goes. Alright, I'll get back. Okay, not a bad run, 1 hour and 27 minutes. We're down to 0.8 volts. And we made 73 milliamp hours and 122 milliwatt hours. So stopping the load. And we sort of bounced back a little bit. Oh yeah, we hit the 1 volt, but we'll see later. I'll come back in a half hour and see if the voltage is starting to drop again. after it builds up and then it starts leaking. So I'll try to bag that up and seal it as good as I can, add some little bit extra electrolyte and see how many charges we get out of it. And as you can see, the voltage has dropped down, so it's really heavy on self-discharge, so we have to sort of somehow stop this cell from self-discharging, and we may get some better performance out of it. Alright, so tomorrow I'll put that in a pouch and see what I can do. And thanks for watching, and I hope you enjoy this video.